In the previous classes, we learned what a qubit is, how to write qubit using Dirac notation, and how quantum states are represented mathematically. But learning quantum computing using only equations is like learning geography using only coordinates. So today we slow down. Today's class is about visual intuition. Our focus is on simple question. How do you see a qubit? And the answer is the Bloch sphere. A classical bit is simple. It is either 0 or on. But a qubit is not just a number. It is a state. So instead of drawing a line, we draw a sphere. A sphere gives us intuition, geometry, and visual way to understand quantum states. The Bloch sphere is the sphere of radius 1 and center at the origin. We imagine an arrow starting from the center and pointing to the surface of the sphere. The arrow represents the state of the qubit. This is not the actual electron or photon. This is a mathematical picture that helps our brain visualizing the quantum states. The Bloch sphere has 3 axes: the x-axis, the y-axis, and the z-axis. Today we will focus only on the z-axis. We will not discuss the other axes yet. We will discuss them later when we learn quantum gates and rotations. Let's place the simplest states on the sphere. The north pole represents the state 0 and the south pole represents the state on. These states are pure states. They are perfectly definite and they are mutually orthogonal. Here a common question is, orthogonal vectors should be 90 degrees, right? That is true in normal vector spaces, but the Bloch sphere is a state space representation, not a vector space. On the Bloch sphere, orthogonal quantum states appear as diametrically opposite points. That is why state 0 is at the top and state 1 is at the bottom. Every other point on the surface of the sphere represents a valid quantum state. These states are not fully 0, neither on. We will explore these states later when we introduce superposition. For the sake of simplicity, we will not discuss the formulas right now. You just need to remember that the north pole corresponds to the state 0 and the south pole corresponds to the state on. Everything else comes later. In quantum computing, the Bloch sphere representation is really important. Almost every concept that we will study later, like quantum gates, rotation, superposition, and phase, will be explained as movement on this sphere. So let's build the intuition slowly. In this lab, Python is just a tool. The goal here is not coding. The goal is to see the qubit. Now open your Google Colab notebook and install Qiskit as we have seen before. This gives us all the tools we need to work with quantum circuits and quantum states. Now let's initialize a quantum circuit with just one qubit. This circuit has exactly one qubit, and an important thing to remember is that Qiskit always starts every qubit in the 0 state by default. Now look at the quantum state mathematically. This output tells us that the amplitude of state 0 is on and the amplitude of state on is 0. So the qubit is exactly in the 0 state. Now let's visualize this state on the Bloch sphere. What you see here is an arrow pointing straight up to the north pole. The north pole corresponds to the state 0. Don't worry about the Python visualization code. Right now, the only thing you should focus on where the arrow is pointing. Now we want to see what the state on looks like. To do that, we apply a single line of code which we have used in the last lab. As we have told earlier, this operation is actually a quantum gate, but we will properly study gates later. Now let's see the state again. The qubit is now exactly in the on state and we can visualize it. Here the arrow points straight down to the south pole. That south pole corresponds to state on. At this point, notice something very important. We are only looking at the top and bottom of the sphere. We are not discussing the x-axis or y-axis yet. We will talk about those axes later after we learn quantum gates and superposition. Just remember this, state 0 lives at the top of the Bloch sphere and state on lives at the bottom of the Bloch sphere. And that's all for today's video. Hope you understand the topics properly. If you still have any doubts, you can ask in the comment section. Make sure that you subscribe the channel and like the video. You can share this video with your friends who are also interested in quantum computing. See you in the next video. Until then, happy quantum computing.